In this video, we take a look at a special application of systems of linear equations. Specifically, we look at a problem that's a little more challenging than the regular interest problem. In this problem, our interest rate is what is missing. Let's start. Nyla invests $2,400 in one account and $2,500 in an account paying 4% higher interest. At the end of 1 year, she had earned $296 in interest. At what rates did she invest? All right. Often when you have word problems, the very first thing that you want to do is you want to identify what our unknowns are. For this specific problem, do you see that we're asking at what rates did she invest? That means we're looking for the interest rate for the account in which she input $2,400 and the interest rate of the account with $2,500. So I'm going to start right away and assign variables to each of these interest rates. I'm going to let X equal the rate in the first account, and then I'm going to let Y be the rate in the second account. From here, what I'd like to do is organize my information, and often you will find that professors and even students like to do that in the form of a chart. So I'm going to put a chart up and see if I can't organize all the information from this problem into that chart. So in this chart, you'll notice our first column is labeled principal. That's the money that we invest in accounts. The second one is the interest rate for that account. And the third is the interest. And to get the interest, we take the principal times the rate. So let me just mark that down quick. Interest is principal times rate. All right, let's organize the information now in this chart. In our first account, Nyla is investing $2,400. And the rate at which she's investing it, we are calling X%. In addition, she is investing in a second account $2,500 principal at a rate of Y%. The interest comes from taking $2,400 times X%, so I'll write $2,400 times X%, and we're multiplying those, and $2,500 times Y%. Now I want to get this and make this a little cleaner here in the interest part. What exactly is this expression here? $2,400 times X%. Let's investigate. $2,400 times X%. What is a percent? This is weird. Like if we write 6%, we write 0.06. If we write 7%, we write 0.07. But X%, well, we could write 0.0x, but that's kind of weird. Instead, I want to look at percents as the fractional representation. In other words, X% simply means X per 100. 6% is 6 divided by 100. 20% is 20 divided by 100. So X% is actually X divided by 100. And that means 2,400 times X divided by 100. Well, I can do a little quick calculation here and do a cancellation. 100 goes into 2,400, leaving me with 24X. In other words, 24X can replace this interest rate right here. I'll just bubble it in. In a very similar fashion, we could also take a closer look at 2,500 times Y%. 2,500 times Y% is, by the same reasoning, 2,500 times Y%, And y% can be written as y divided by 100. So let's write that as y divided by 100. Let's do a really quick little cancellation here. And that gives me that the principal times the rate for that last column is simply 25y. And that's the expression that I can use to replace in this box right here. So let me make that replacement so it makes it nice and cleaner. I'm going to clean out this area here. And I'll clean out this area here. Whoops. And instead, I'm going to write for that first interest, 24x. And for the second interest, 25y. Beautiful. Now, what do we do with the information once we get it in the chart? Remember, we're solving systems of linear equations. And to solve a system of linear equations, we need two equations. Usually, the equations come from the first column and last column if you're using a chart of this form. But in this case, we're going to actually make equations from a chart using these two columns right here. We're going to use the second column and the third column. The first column really doesn't tell us anything because we just have principal numbers added up. But these two columns here, the second and the third, actually have variables with which we can write two equations. What is our total interest? Remember, we're adding the first account to the second account, and that's giving us a total right here. So what is our total interest that we're gaining? In the first account, our interest that we're earning is 24x. In the second account, the interest we're earning is 25y. We are told in our problem that Nyla had earned a total of $296 in interest. So that means that 24x plus 25y has to equal 296. In other words, the interest earned in the first account plus the interest earned in the second account has to equal our total interest. What are we told about the interest rates? We are told about the interest rates that we have one account, but then we have a second account that pays 4% higher interest. What does that say? To me, that says that this account has 4% more than the first account. Let me write that down in words. So the second has 4% more interest, or operates at a rate that is 4% higher than the first. And how do we translate that into an algebraic expression? Well, the second account we were representing with the letter y. And the first account, interest rate, we were representing with the letter x. And so this then translates in my head to saying y% must be equal to 4% plus x%. And that creates our second equation for this system. From those rates, we get the second equation that y equals 4 plus x. That's the system of linear equations that I want to use to solve this problem. Let me write it down again. 24x plus 25y equals 296. Y equals 4 plus x. This is now a system of linear equations, and it's set up beautifully for us to apply the substitution method. Do you recall the substitution method? The substitution method is when we pick one of the equations and solve for a variable. So notice our second equation is already solved for y. So we take that expression, y equals 4 plus x, and we use it to replace in y in the other equation. So right here, we're simply going to replace the y with 4 plus x. That gives me 24x plus 25 times 4 plus x equals 296. Now I'm going to do a quick little distributive property here. I'm going to take 25 times 4 and then 25 times x, and that's going to give me that I have the equation 24x plus 100 plus 25x equals 296. I'm going to continue solving for x, so that gives me that 49x plus 100 equals 296. I'm going to subtract 100 from both sides, subtracting 100, and that gives me that I have 49x equals 196. One more calculation, going to do a little quick division here. Divide both sides by 49. And that tells me that x is 4. Awesome! That's our first rate. So now we go back, we plug 4 into one of our original equations. I will choose the second one that says y equals 4 plus x. And if x is 4, I do another back substitution and I replace x with 4. And that tells me that y is 8. Let's state the conclusion then. Because we had very nicely at the beginning of the problem written down what x was representing and what y was representing, we can now label x and y as part of our solution. X is the rate of the first account. So that means that my first account has an interest rate of 4%. Similarly, y was the rate of our second account, and so that means the second account has a rate of 8%. So Nyla invested money into two accounts, the first of which was a 4% interest rate account, and the second of which was an 8% interest rate account. Of course, it's always important to go back and check and make sure these values work in your very first equation right here. So I would go back and take 24 times 4% plus 25 times 8%, and you will discover it does in fact equal 296. So our solution is first account is 4% interest rate, second account is 8% interest rate.